Hey guys, so solving the third part of this cube question. Now in this case, you're supposed to find out what will be your effective resistance across AC, right? So already have the diagram here. So let's start labeling potentials in this case right now. So once again, we'll be making use of the same idea. We'll try to find out points of symmetry over here, right? So let me say this point is potential E, this point is potential 0, right? And now let me assume that this point has a potential V1. Now this point is located on the edge with respect to input and on the edge with respect to output, right? The other point which is located on the edge with respect to input is this, and that's also located on the edge with respect to output. So even this point will have a potential V1, right? And the other point which is located on the edge with respect to input is this point, but that is not located on the edge with respect to output, so that will have a different potential. Let me mark its potential as V2, right? Okay, then let me assume that this point has a potential V3. This point is located on the phase diagonal with respect to input and on the phase diagonal with respect to output. Even this point is also located on the phase diagonal with respect to input and on the phase diagonal with respect to output. So the potential of these 2 points will be similar. So even this potential will also be equal to V3. And then this point, let's say, is equal to V4. That's located on the edge with respect to input, body diagonal with respect to output. So no other similar point of symmetry over here, right? And now let me redraw the circuit diagram. So the points of potential I have is, so here I'll redraw the diagram this way because E is connected to both V1, V2, and V3, V4, and 0. Right, okay. So now between E and V1, we have two resistors. So between E and V1, we have two resistors. Between E and V2, we have only a single resistance. So let this be a single resistance. Between V1 and V3, we have two resistors. Between V1 and V3, these are the two resistors we have. So two resistors between V1 and V3. Between V2 and V3 also, we have two resistors. These are the two resistors between V2 and V3. So two resistors between V2 and V3 as well. Between V3 and V4, we have two resistors once again, this one as well as this one. So between V3 and V4, two resistors. Between V4 and 0, we now have a single resistance. So between V4 and 0, single resistance, right? And one more thing which you're left out right now is also there's a connection between V1 and 0. So between V1 and 0, we have two resistors. So let me draw the diagram this way. Between V1 and 0, I have two resistors over here, right? So R and R. So let's take care of the obvious parallel paths first. So this will be R by 2. This will also be R by 2. This will also be R by 2. This will also be R by 2, right? And we see that R by 2 and R are in series. So this will become equal to 3R by 2. And this is also equal to R by 2, right? So now even this R and R by 2 are in series. So this will also become equal to 3R by 2. So drawing that circuit diagram once again, I'll have E, V1, V3, and 0. Between V3 and 0, the effective, okay, so between E and V1, the effective resistance was R by 2. Between V1 and V3, the effective resistance was R by 2. Between E and V3 itself, now we have an effective resistance of 3R by 2. Between V3 to 0, we have an effective resistance of 3R by 2. And between V1 and 0, we have an effective resistance of R by 2, right? So now if I redraw my diagram slightly this way, I hope you might have already seen this, but let me redraw the diagram just in case. If I write this as E, V1, V3, and 0. Between E and V1, we have R by 2. Between V1 and 0, we have R by 2. Between V1 and V3, we have R by 2. Between E and V3, we have 3R by 2. And between V3 and 0, we have 3R by 2, right? So what you notice is we have a balanced Wheatstone bridge, which means this resistance is useless. So R by 2, R by 2 are in series, that is R. And then these two are also in series, that is 3R. So your effective resistance R and 3R are in parallel. So our R effective then will be equal to R into 3R by R plus 3R. So that will become equal to 3R by 4, right? So hopefully all these three cube questions were clear. See you guys in the next video. We'll also solve similar questions to this.